Hey guys, this is EE542 Final Project Practice Talks number 3. This is Stan Group. So before we actually get into the slides, so the challenge that we are picking is FDA mislabeling correction subchallenge number 2, and this is the story of how this why this is important. And also, this is the problem that we are actually facing, right? So there are 3 type of data, and there are relationship between them. And the goal is to finding the mislabeled data, and the second one is to correct it. All right, so this is our problem that we have, and this is our solution workflow. Right, as you can see here, it's divided into subchallenge number 1 and subchallenge number 2. So to begin with, we're actually doing a feature selection out of proteomic data because it have over 4,000 features, and we are not going to use all of them. And after we finish the feature selection, we are going to use the selected feature to build a prediction model, which is to use proteomic data to predict the clinical data. And after that, we are using the same models to do the prediction here in the subchallenge number 2, and still in the using proteomic data and clinical data. Right, so after we made our prediction, we're going to check if our predicted clinical data is the same as showing the given data set. Alright, so if we got the correct prediction, so we know that RNA data is mislabeled, right? Because only one of those 3 data is mislabeled. So if we know that RNA data is mislabeled, we're going to build a model to predict RNA data. So what if our prediction gives a wrong result? If our prediction gives a wrong result, means one of the proteomic data and the clinical data is mislabeled, right? So after that, we got to we have to know that which one is mislabeled out of proteomic and clinical. So there are basically 2 ways. One is to use RNA data to check proteomic data because there are many overlapping features, right? The second one is to build a model to use RNA data because if we are going this way, we can assume that RNA data is correct, right? So we use RNA data to build a model to use RNA data to predict one of the proteomic data or clinical data. To use that model, we will be able to know which one is mislabeled, so then we are going to make a model to predict it. This is our workflow, right? So this is what we are doing this week. So we are working on the feature selections, and so there are six type of method, 6 feature selection methods, right? So first 4 is univariable selection with different models, and the other 2 is RFE, recursive feature eliminations, with 2 different models. So we also have three type of preprocessing methods, and one is merge and sort features by rank sum. The second one is merge 6 sorted array, which are 6 result features from 6 different feature selection method in order. The third one is to sort features by overlapping types. The reason why we have this is because different models, different feature selection method could give a different result because perhaps they can find the different angle of this data and this data. So right, as we can see here, so we want to have more consideration from multiple perspective of those data set. Right, so this is the workflow, feature selection workflow before we actually doing the experiment. As you can see here, the reason why we designed this is because lasso selection cannot handle large amount of features, right? So it's pretty natural that we're actually going to reduce the feature numbers, right, from a huge number to a number that lasso selection can handle. So the first feature selection part, we are going to use the the listed 6 feature selection method. And after that, we're going to do a preprocessing method as we listed here. And after that, we're going to do lasso selections. And after we got selected features, we are going to use those features to build a predictive model. So this is our result. As you can see here, after we handle missing data, we have 1085 features. So among those features, we are using univariable selection with the F classifier to do the first featureless selection. So we got 100 features, and after that, we are going to use those 100 features to do lasso selections, and we got 22 features out of it. So we are going to use these 22 features to build a random forest prediction models. All right, so this is our result. This is the features that we select, and this is the elevation evaluation metrics, as you can see here. Right. So the reason why we choose random forest, because sometimes logistic regression model will give a better result if the features are selected using recursive feature eliminations with logistic regression model. The result is going to be really good because you're using a logistic regression to choose features, and you put those features into a logistic regression model, so they'll be overfitting. But we are focusing on using random forest, because random forest is pretty good to prevent overfitting, and also is pretty suitable for a scenario when we have many features. So this is this week's talk practice. Thank you.